Thank you for joining us today. I'd like to welcome you all to the Construction Futures Research Centre webinar, How Virtual Reality and Augmented Reality Can Help the Construction Industry. My name is Paul Davis and I'm the Knowledge Transfer Manager for the Construction Futures Research Centre. I know it's the longest job title in the world, but thank goodness for acronyms, so I'm the KTM of CFRC. Before we move on to the main event, I would just like to tell you a little bit about CFRC and what we do as a project. We're a project based at the University of Wolverhampton and part funded by the European Regional Development Fund. We offer fully funded support to SMEs in the Black Country region. I'm not allowed to say free, but suffice to say it won't cost you anything. We offer smart productivity improvements for off-site design and manufacture and construction. And the University of Wolverhampton has a wealth of academic experience in architecture and the built environment, and our support allows you to tap into this resource. We offer various services, for example, discrete event simulation. Decisions made early in the design stage can have significant time and cost impact on manufacture and construction later in the process. Advanced tools and techniques mean we're able to simulate the entire process right through design, manufacture, installation and operation of built assets. In other words, you can try different scenarios in the virtual model for a fraction of the cost of experimenting in the real world. We also do building information modelling, but that will be discussed in a lot more detail by David Heason later, so I won't go into that too much now. But suffice to say, BIM is a big part of the CFRC offering. We offer support right across the supply chain, for example, helping architects optimise their modular house design so that it is cost effective to manufacture, carrying out laboratory tests on components used in the built environment, to advice on introducing BIM into an organisation. And CFRC employs digital techniques such as artificial intelligence, virtual reality, augmented reality to help develop more efficient workflows. CFRC is also aligned with the University of Wolverhampton's £100 million project to create a major construction research and innovation centre. Springfield, which was shown on the background of the first couple of slides, will be the world's largest construction education campus on a 12-acre site near the city centre, housing the School of Architecture and Built Environment, and the building is due for handover in just a few weeks' time. The ultimate aim of this project is to improve the efficiency of the construction sector and develop new methodologies to simulate processes in the construction and infrastructure sector and to propose efficiency improvements, especially related to housing delivery through off-site or related techniques. The underlying research focus of the project is to collect real-time data from industry, develop real-time process simulations and perform analysis on process improvements for different stakeholders who are working in different roles within the construction supply chains. By undertaking this, the project will foster a process improvements systems for companies involved, which will lead to the development of groundbreaking methodologies for process simulations and significant productivity and efficiency gains for the region, impacting housing and also major infrastructure products. We're passionate about technology at CFRC and firmly believe that problems can be solved by deploying the right tech in the right way. And this leads me now to hand over to our resident tech guru, Dr. David Heason, reader in building information modelling at the University of Wolverhampton, and our guest speaker, also a tech enthusiast, Dr. Nigel Moore, Technical Director of Seeable. So I'll hand you over to Dave. Thank you.
Well, thanks, Paul, and good morning, everybody. It's great to virtually see so many people attending in this new way of meeting up, I guess. The only concern is that once we start physically meeting everybody again, we'll have lost the ability to communicate face-to-face if there's not a screen in front of us. So we'll have to see how that one goes. Well, it's great to see everybody here. We'll just introduce ourselves. As Paul just said, my name's David Heason. I'm a reader in Building Information Modelling, BIM, in the School of Architecture and Built Environment. I'm also the academic research lead for the Construction Futures Research Centre that Paul's just given you a little bit of background about. little bit background about me and where I've sort of come from, a little bit of history. Prior to joining the university some 20 years ago now, just over 20 years ago, I was an infrastructure engineer for Atkins, and I got sort of at that point got interested and involved in the 3D modelling side of things when it was very new, a little bit clunky, I guess, compared to what we are today. And through the period that I've been in the university, I've been sort of working within the university, but also spending quite a lot of time working outside with various different companies. And the research focus in that time, which I'll talk a little bit more about later on, and some of the areas that we've looked at, has been around BIM before it was BIM, before it was cool, around 3D modeling, and also around sort of VR and some of the applications of virtual reality for construction. I'll let Nigel introduce himself, and it probably gives a bit of a background as to how Nigel and I came to know each other and how we all became involved with Seeable as well. So I'll just let Nigel give a brief intro to himself, and then we'll crack on. I think you're muted, Nigel, at the moment.
Fantastic. So, good morning, everyone. I hope I'm not muted anymore. And Dave will tell you I do have trouble with muting my my mic when we're having virtual meetings. So hopefully I won't be doing that again. So yeah, my name's Nigel. I'm the technical director at a local company called Seeable. We specialise in interactive visualizations and apps based around technical data, BIM, etc. I know Dave since about 2006, when I decided to go back to Wolverhampton University as a late a sort of later in life option, where I studied under him to do a virtual reality design degree. I stayed on and did my PhD also under Dave, which was where I designed where I was looking at construction scheduling and the use of AR and how that might improve the construction scheduling process. I'm very passionate about building information modeling and immersive visualization, and VR in particular. Nothing really substitutes experience something at real time and at real scale. So yeah, great to be here this morning and to speak to you all. Cheers, Dave.
Okay, thanks, Nigel. So our sort of thoughts for this morning, and just to give you a bit of a flavour as to how we're going to run through this, we thought initially we'd give you a bit of background on kind of where things evolved from in terms of virtual reality, and particularly within the construction sector as well, but let's look at the technology. We then wanted to sort of jump in and look at the different approaches to VR and AR, and what the differences are, and you may have picked up on some of them, but we also wanted to then look at what our journey's been and how we've evolved, and what sort of technology we're now looking at from a application point of view and from a research point of view to bring into the industry. And then from there, pick up on some of the technology that's available. Some of it you may have heard of, some of it you may not have heard of yet, to give you a flavour of that. And then to sort of wrap all that up and give it some real context, Nigel will pick that up and he'll talk about some of the really cool projects that Seeable have done using that technology. So that'll give you a flavour of the sort of real world application for it. So hopefully that will cover quite a lot of information in the next sort of 35 minutes or so, or something like that. So I saw this little graph on Twitter a wee while ago, and I thought it was brilliant because it kind of explains, I think, where we've been, where we've come from. Because we started off in terms of the 1990s and where we started talking about it, and it was, everybody thought it was awesome, it was really cool, and then Hollywood got hold of it, and we had films like Lawnmower Man, and we realised that the technology that we've got couldn't really sort of do the things that we thought it should be able to do, and so we all got a little bit deflated and we lost some interest in it, and then it's now picking back up again, so we're now getting to the stage where we all think it's awesome again and we all think it's great. So I thought that was just it. It's quite a brief sort of snapshot of where we are. But I think this, just to sort of, let's develop that a little bit further. And if we went back to sort of, the mid-90s, where the term sort of virtual reality came from, Jaron Lanier, where he developed that. In the 90s, we sort of had really basic computers, and some of the things on there, these are all the things that we've used and I've used in the past. So if you look, we have the sort of Superscape, and we have the big headsets and things like that. Now, and then you move into the 2000s, and things started to get a little bit more technologically advanced, and we had bigger sort of display systems, and the software got a little bit more intuitive, and it got a bit more complex, and we could do better things with it. Now, and then we get to where we are. Now, the reason I always talk about this as almost like the sine wave of where we are, because I think we had the first two sine waves from a construction point of view. I believe they were almost very driven by technology. We had some technology, we sort of used it. It didn't really deliver exactly what we wanted, or for other reasons we didn't pick up on it, and so it kind of dropped off again. And as an industry, we kind of lost interest, and then it picked back up again in the sort of second wave. If we were going to keep on to this wave analogy, that it started to pick up a little bit more in the 2000s. The technology got a bit better, but one of the issues there was that we were a 2D driven industry. We weren't we weren't working in 3D. So there was another stage there. We had to turn our 2D into 3D. And then we hit the 2010-11 stage of things, and we've almost reached this kind of great precipice, this almost singularity point now, where the technology is evolving exponentially. I mean, we've gone past, for anybody who knows sort of about some of the old discussions on Moore's law of computing, where power would sort of exponentially increase every 18 months. We've blown straight through that. So computing power is exponentially increasing. But also, from a construction point of view, we are working in 3D. So it's not alien to us. We understand it. We can now work in that environment. So we have data. And I guess the final thing that's really transformed it now is we have this social transformation as well. So just as we've seen in the last 12 weeks or so, something like that, we're quite happy to work in virtual environments. Or if we weren't happy to start with, we are now. We're all getting quite used to this. And that's an area now that's starting to really get some traction in terms of sort of collaborative VR and working in this virtual environment. And we'll look at some of the tools specifically for construction later on that exist for that. So I think we have this wave period of virtual reality that came in. And I think towards the back end of it now, we've really hit this point where this stuff is just taking off into the stratosphere, and it's going to get really exciting. And I think it's going to get really exciting really quickly as well. So that's a little bit of background. We'll unpack some of these bits of sort of tech and software, etc., as we go along. But just to give a sort of an overview. I also think if we overlaid on that, on the top of it, what's happened is, for those of us who were sort of around in this area back in the 90s, the cost for any of this technology was high. The cost for sort of the hardware was high. The cost for some of the software was high. As we moved through sort of into the 2000s, the noughties, things started to get cheaper. Computing became cheaper. Software costs were still high, but started to drop in comparison to what they were. And then we get to where we are now, and costs are dropping even more. We'll talk about this in a bit, but you can go down to Argos now and buy a virtual reality headset for 400 quid. You can use VR software that's open source or is free to use. So in terms of that, add this as an extra layer, an extra dimension, an extra layer on, we're now also seeing cost drop, which means it becomes more sort of available to us as an industry. And just an extra point on top of that is, and this is kind of from my personal experience of using this tech for the last sort of 20 odd years, is the usability has become far easier, I guess, if that's the right phrase to it. And I kind of wasn't sure whether that green line should be going that way or the other way, but essentially, if I look back in the 90s, even in the early 2000s, to generate any kind of real-time simulation, I would need to program in, I'd probably need to be in C++ or some kind of programming environment to get something really cool out of it. Whereas now I'm moving into, we're using games engine technology. It's drag and drop, or some of it is you just load your sims into it and you can access it and you can interact with it. So I think that on top of all the other things that we mentioned means that we're starting to see this kind of real transformation where we are. So just to set a bit of a scene overall before we specifically sort of look at construction, you can see that there's been some market reports done because virtual reality is becoming the big thing. And if we look at this one, okay, a lot of it's driven by games, and we see that now, and it's great to see. I love watching my daughter now play Minecraft, and to me that's amazing because when I watch her, she's building a 3D environment, but at the same time she is chatting with her friends, and they're collaborating as they're building. And they're talking about what the design should be, and they're making changes on the fly, and they can see each other in that environment. But putting the sort of BIM perspective on, that's BIM. That's part of it, the collaborative working process, working in 3D. She's doing it. She's 12 years old. She's doing it, and she's doing it with her friends. That gives me amazing hope for the future of where our sort of industry might be going. Well, you can see the console market's driven VR, but also the PC market, and that kind of tells us that there's a lot of sort of PC-driven, commercial-driven work going on. And if we look at some of the numbers are phenomenal in terms of the market for this. We're looking at sort of over $120 billion market come 2026. These numbers came out pre-COVID, whether that will change anything, but it's still showing it growing. Now, if we contextualize that in terms of the construction sector, and we're almost starting to follow that trend. We're a little bit lagging behind, I think, but then generally speaking, I think in terms of technology, we do tend to lag behind a little bit, and then we catch up. Well, there's been some studies done recently. It's certainly been a recent one this year, only a couple of months ago, that was published, which demonstrates that the current usage of VR now is starting to show more and more people are starting to use it. There's around 30% who are not using it at all. There's sort of around about 40% who have seen demos, or maybe they've attended things like this, and it's something that's on their radar, and they're starting to think about it. And there's a good sort of 30% of people who are using it in the industry. And then if you look at and how that might go in 5 to 10 years' time, well, we start to see things change. We start to see people, well, yeah, okay, we'll definitely be using it. We'll probably be using it. So we start to see at least 60% of people thinking that they will be using it in the next 5 years. Or they may be. So we're up to 80% of people there who think they are. And then if we look at, there's been an RIBA study from an architect's perspective that's showing that some sort of 35% of practices are using it now, with sort of another 30% who are thinking, they will be using it very soon. And if you underpin that, obviously the government are seeing a value in this because they've sort of released in the last sort of year or so this big tranche of funding through Innovate UK to support research projects and demonstrator projects around the use of virtual reality in the construction sector. So that gives us a bit of confidence that this thing's here, this thing isn't going to go away, this thing is actually of value to us as well, and we're now starting to see that sort of value proposition coming through from virtual reality. It's no longer a toy. And I know even I'm guilty that sometimes we refer to it as, oh, it's the toys, let's go and play with the toys. And I guess some of that language hasn't helped in the past, where we thought of it as a toy. It's a productivity tool. It's a viable productivity tool that we're using and that we're talking about here. So just to give you a bit of context as to from the university perspective and some of the things that we've done kind of overlaid onto that timeline. And I mentioned earlier that we started in the kind of late 90s at the university. And we have the sort of traditional very bulky headsets, the great big headsets. And what happened is in the early 2000s, back in 2001, we moved away from that and we built what then a lot of people were starting to get interested in. We built an 8 meter, I think it was 8 or 10 meter, 150 degree curved screen. So you can see it on the picture in the top and the middle there. And the reason we built the curved screen because we could fit more people in there and we could have collaborative sessions. So we could have designs up on there and we could have sessions, interactive sessions where lots of people could interact and engage with the design and discuss it. And that technology used something called passive stereo, which is where you have two projectors on top of each other, both projecting onto the same space, but a slightly different image. And then you put the glasses on and that comes off the screen and becomes 3D. It's the same technology that's used in cinemas when you go and watch a 3D movie in the cinema and you put those kind of funky glasses on. In fact, as a prop, those are the glasses that I'm talking about in the cinema. Now, downside with that, it cost us well in excess of £250,000 to build that back in 2001. The maintenance on it was daily, and you couldn't have a lot of people interacting with it, particularly at the same time. Although you could have a lot of people in the space, only one person at a time could do that. A little bit later on, we took that out and we rebuilt what we call the power wall. So it's a 5 meter by 3 meter stereoscopic wall. The wall is just a plasterboard wall, skimmed, whitewashed. That was it. We bought a big projector which hangs and produces something called active stereo, which is where the projector itself shoots two different images out to create a 3D image. And you put on, you can see the small glasses on the bottom there, they're called shutter glasses. So the glasses actually switch on and off. Each lens of the glass goes black to transparent, around about 120 frames a second, 120 hertz. What that does is it tricks the brain into seeing 3D. So a lot cheaper. We paid about £50,000 for the projector to build that, and there was no specialist screen. It was just a wall. So then we started to talk to. We actually bought a portable version of that as well for a few thousand, because we could take that on site. We could project onto porta cabin walls, and we could start to get people engaging in 3D in the porta cabins and having discussions around it. So that still exists today. It's still in the lab today. We can use. We've moved on again, and we've almost gone full circle. And this is happening a lot now, and we're starting to see it happening with the industry as well, because now we're moving back to headsets. So we're moving on to the smaller headsets. They're cheaper. They're consumer level entry. So, and they have enough computing power within themselves to not need a high-end PC to drive it. I should have said that with both of those other two setups we had some significant PCs driving those machines, which again added to the cost. So we're now back at, we're sort of now using headsets. We are investing in virtual reality treadmills as well. If you haven't seen them or you haven't come across them, it's a new way to interact with the environment. You strap in, they are omnidirectional, and you can go walking around the site with your headset on. So for anybody who gets any motion sickness when using VR, which a lot of people do, it kind of removes that, because you're your legs are actually moving, so you're walking. So the signal from your brain, your legs are telling your brain that you're walking. You're seeing the simulation in your eyes. It reduces that level of motion signal. So we're investing in them. We bought one of the first generations, those in the lab, and we've tested it out, and we've used that with some architectural practices, and we've used it with some contractors as well to do sort of site orientations and walking around, and the initial results are really good with that. Paul mentioned the Springfield campus. It's a huge investment by the university. We're building the new School of Architecture and Built Environment on there, due to open this September. As part of that, we have developed a certain area within the building, and we've created something called the construction holodeck, which is going to be the next generation of visualization center for all of our students who study in architecture, engineering, and construction. So it's coming along soon. We're developing it. It's going to have some of the latest tech in terms of the treadmills, in terms of the big screen, in terms of the headsets, and in terms of sort of the spatial-based VR. So something that if you're interested in, certainly when it's open, you're all welcome to come and see it, see how it's working. So that's a little bit about our journey. In terms of, there's now this other thing, which is augmented reality. So we have virtual reality, and I think we're kind of fairly okay with that now. It's a completely virtual world. Back in 1994, some guys published this, what we call the sort of mixed reality, or the virtual reality continuum, which is this thing that you can see here. And essentially it goes from the real world right through to the virtual world. And somewhere in between that, we have this new thing, which is augmented reality, which is what we're now starting to get really excited about, and everybody's starting to get really excited about that. Now, it did start as two different things. So we did have augmented reality and augmented virtual reality. I guess what's happened over the last few years is those have almost kind of blurred together slightly. And we have this thing that now we sort of think of as AR. And AR, for anybody who's not come across augmented reality, remember a few years ago, Pokemon Go over the summer everybody was a craze, everybody was into it. And we were overlaying a virtual object onto the real world. And that was kind of the first real consumer level entry into VR, into AR, sorry. Google now are doing it with Google Maps. So you can have directions overlaid onto your maps as you're walking. And from a construction point of view, now we're getting interested in this because it means that we can have our virtual world looking like it's in our real world. So we're blurring the lines between sort of virtual and real. Some examples on there. We're now starting to get into AR headsets that we can have on site as well. Talk a little bit about that technology in a few minutes. So we have these sort of different areas, and we can use it in all areas, whether it's design. It's all driven from BIM because we have the data. We have 3D data now. BIM is a much bigger topic. It's working processes, it's digital data, it's capturing that, and it's also 3D data. So that kind of drives it. So we can use it in the design, we can use it in operation, we can use it in the actual construction phases. And we have the opportunity in all those phases to implement VR and sort of AR. Now, in terms of let's start with the VR side of things. There are different sort of typologies, if we want. So there's desktop VR. In other words, I can just be engaging in the 3D world interactively in real time. That's the thing about virtual reality, is it's what we call real time simulation. So we interact with it as we do something, we get something back from the world. So as we move forward, the viewpoint changes. As we click on an object, maybe the door opens, maybe whatever it is. It's real time interaction. Makes it very different to an animation, which is just passive. It's like watching a movie. So we have desktop VR, where we can interact with that 3D environment just through the window on the world, almost like through your monitor. And then we have sort of this partial immersive level, and we have fully immersive. So when we're talking about sort of fully immersive, then we might be, we're in the headsets. Okay, that's great. And we're actually interacting with it through the headset. So we might be walking around it on the treadmill, or we might be sort of dragging things around. You can actually design in VR now. So that if you buy some of the headsets, you can actually draw and design in VR. And we've seen a car done like that from scratch. So you're building in virtual reality. Where will that go? Who knows? Maybe in the future we'll be creating worlds. If we're using Revit, perhaps we'll be in the virtual world and we'll be building them there, rather than using the mouse and keyboard. When one thinks about it, the mouse and keyboard, we've used that way of interacting with the computer since day one. And if we're in between that partially immersive, maybe we're in the headset, but we're not, so we're immersed in it, and we're in this virtual world, but we're not able to interact with it. So something like some of the things you see on Samsung Gear. On the augmented reality side, we have two different types of augmented reality. So we have marker-based and markerless. And marker-based is, maybe some people have seen this, where you have a QR code, or you have something on a piece of paper, and when you look through your iPad onto the piece of paper, the 3D world pops up. So that's marker-based AR. Markerless AR that's something that we're starting to develop, and Nigel actually developed his PhD around this some nearly 10 years ago now, actually, the markerless AR, where you don't need a piece of paper, you don't need anything. You can be out in the field, you can be on site, and it'll understand where you are, and it will overlay the virtual world onto the real world for you. That's markerless AR. A little bit more tricky to get right, and a lot more expensive. That's why a lot of the work in terms of augmented reality that we see at the moment is marker-based. So it's kind of static. Just in terms of the technology that we're looking at, if we look at some of the headsets, and I'll try and give you an idea in terms of some of what some of this technology is. We've used, I think, all of these that we've got here, most of the headsets. In fact, all the headsets, we've bought them and we've tested them out, we've trialed them, we'll see how they're working. So you start off with the very cheap entry level, the Google Cardboard, which can work on your phone, or you get into the Samsung Gear, which again is phone based, but it's a really cheap solution. The Oculus Rift and the Vive, they're sort of a little bit more expensive. You're starting to get into the sort of few £100 up to the Vive level, where you're looking at probably about 1,000 for a Vive Pro. The resolution of those is getting better all the time. The downside with them is what we call the tracking. So they track the movement of the person in the virtual world by having sort of optical sensors or infrared sensors, should I say, that actually track where it is. So that little picture at the top with the human standing in the middle of it, it senses you in a certain space, so it knows where you are in a certain space, and it tracks your movement through that, whether that's in any of the degrees of freedom. Downside of that is you're locked into that certain space, you can't move around. That all changed recently with the delivery of the Oculus Quest, which has something we call inside-out tracking. So the Oculus Quest is a completely standalone unit. The thing with the other two units there is they have to connect to a computer. With the Oculus Quest, it doesn't. It's sort of on its own. It's a computer on its own almost, if you like. But it looks and it understands where you are in a specific space. And the cost of that is 400, 500 quid, depending on the amount of memory that you buy into it. So the headsets now, there's some great ones. We're at the moment, we're really sort of getting into the Oculus Quest, as I know Nigel is, and some of the things that the guys are doing there. So one to look at. In terms of the augmented reality hardware at the moment, now there's been some changes on this really recently, because we did have a company called Meta who developed these, and these are like the standard glasses that you see, but you can see through them, transparency, but they're also projecting onto them at the same time. So we had a company called Meta who were developing it. We had the Magic Leap, which were developing a headset as well. But almost kind of usurping all those was the Microsoft HoloLens. And the Microsoft HoloLens 2 is now being developed, and that's people like Trimble are looking at that, and they've done some work with it now already. So if that's something you're interested in, I'd kind of suggest you head over to maybe have a look at Trimble, their website, because they've started to do some work on this. Apple are allegedly due to release their own augmented reality headset coming soon. Nobody really knows much about it. It's a bit cloak and dagger, but we can make the assumption it's going to be pretty cool. And then the other thing that's on here is some of the omnidirectional treadmills, and the ones that we're particularly looking at. And these allow you to walk around the world without being tethered. So you're not constrained in a certain space. It becomes much more useful. In particular, we started to get involved with them. We started to get really interested in them. We were doing a research project with a contractor who was doing fit outs on nuclear sites. And the time is of the essence whenever anybody is on the site, because they've got to get on and get off, and it all depends on how much they're being exposed to. And so we started to look at this as a way of really, truly rehearsing some of the work they did on site and knowing where they were going to go, understanding the route paths, to minimize the time on site. And that's where we started to get interested in these. We bought one of the first generations, and actually it worked really well because we started to generate a new level of immersion, a new level of engagement for the people who were inside the virtual world. So we are purchasing 4 of these treadmills. The one on the top right is the one that actually we're buying. It's called the Catwalk Mini. We're buying 4 of those. We're putting those into the holodeck, and we're networking them up so that you can actually have almost complete virtual team meetings, or you could run training sessions, sort of walk around the site in a way that you would do normally. Software. Now we've sort of evolved again now. Games engines are starting to become prominent. So if you look at Unity and Unreal Engine, 2 of the biggest games engines that there are, a lot of the things that are done on PlayStation and Xbox are created using those. These, and they're free. You know, for some of the versions, they're free. All right, if you go into the big commercial versions, but generally, and I know Nige might talk about these because he uses Unity a lot, they're of no cost to buy them. Now, the interesting thing is the guys who developed this started to realize that more and more people in the construction sector were using them. So Unity teamed up with Autodesk, and they've created something called Unity Reflect, which is almost, in some ways, a simplified version of the games engine, but it's very, very focused on construction. So it takes data in from Revit. The release that came out the other day now takes information from Navisworks. It's bi-directional, so if you make a change in the Revit world, it updates it into the VR world. You can generate that markerless AR from within Unity Reflect as well. It really is, it's one to watch. If you haven't come across it before, definitely something to dig into a little bit more and find out about. Similarly, Unreal Engine, they purchased Twinmotion, which was a VR tool, and that now has become, Twinmotion is now using the Unreal Engine, graphically outstanding, and also a release now, they can bring in really high quality point cloud data into Twinmotion as well. So if you're using that, it's well worth a look. Where things are getting interesting from that collaborative side of things is sort of looking at using the VR world, but having more than one person in it and engaging in it and doing collaborative work. So that really is the kind of BIM philosophy, the underlying BIM philosophy of doing it. And there's some software packages available for that you can purchase at the moment. So Insight VR, Iris, Rehearsive, which is come from one of the contractors in the Well worth a look at them to see how they actually sort of work. But it's more collaborative. It's collaborative VR, and that's going to become the thing. Just for a little bit of kind of entertainment, some of the stuff in terms of VR probably no much use to us as a construction sector, but actually some really other cool stuff going on in terms of audio modeling to create binaural simulations within it. Smells, people are now building smells into virtual reality. So touch, there's a company called Ultra Haptics who are building in physical touch into the virtual world. And there's even some guys who are generating taste, and it's electrodes, and you can actually taste things from the virtual world. Something that I don't think is going to hit us as an industry, but it's kind of fun to watch. And just something, food for thought, this is a research piece coming out of Microsoft, but I think in terms of where we've been for the last 12 weeks, definitely some food for thought. With that, we talked about the HoloLens augmented reality glasses. Microsoft are developing something that they call Holoportation. For anybody who's into sci-fi movies, Star Trek, or Star Wars, or anything like that, it literally is kind of sci-fi. So if you have a watch of it, and we'll put the link up to go to the page, but if you search Holoportation from Microsoft, it's now bringing in holograms of people into meetings. So whereas now we're doing it through a webcam and through this, or if I'm teaching a big class, or if we're on site having a site meeting, and we might do it on a big screen, there's potential for that in the future now, probably not too far away for us to be looking and discussing holograms and chatting with holograms. Or if we're doing walkarounds on site or toolbox talks, then we could be potentially doing that with holograms. So holoportation is definitely something to watch. So that gives you a little bit of, I've kind of guess a little bit on the techie side, and trying to give a bit of a background, a bit of flavour in terms of the technology side of things and where things are and where we might be going. But I think to put that into context to show that this stuff has really been used in earnest, and it works, and it's been shown to give tangible benefits. I'll hand over to Nige, and he can talk about some of the stuff that Seeable have done. Seeable have been like at the cutting edge of some of this stuff for the last six or 7 years now. So you'll get to see some of the actual projects that these guys have been working on. So Nigel, I'll hand over to you.
Yeah, thanks, Dave. Cheers. Great presentation as usual. So yeah, I'm just going to I'll be whistling through these a little bit, because you guys may have some questions at the end, and I just want to leave a bit of time for that. So yeah, I mean, Dave's touched on this, but back in the day, I've always been into VR, the idea of VR, and I loved Lawnmower Man, even though it really did my industry a massive disservice by kind of giving people the impression that it was farther forward than it actually really was. However, so this is a little kind of background to VR in Seeable. So from the bottom left, we've got, the very simplest, and right from the word go, we wanted to get VR into people's hands. We didn't want, we've always been able to throw a lot of money at VR, and if you've had enough money, you've been able to get something pretty impressive. But really, for me, it's getting it into people's hands in a usable way that makes it really powerful. So yeah, in the middle there, we've got the good old Google Cardboard, which we've used for lots of virtual tours, or for people like the Antarctic Survey, for sort of architects who wanted to visualize stuff. And then the bottom right there was the first really kind of interesting commercially available headset, which was the first Oculus Rift. I don't think it was called a Rift then. I think it was called the DK1 or the DK2 or something like that. So yeah, so I have a little bit of history with Wolverhampton, so I thought I'd just drop this in. So this was from about 6 years ago. And Dave mentioned Window on the World, and we've very much employed the Window on the World version of virtuality, again, because it enables us to get interactive 3D content in front of people. So here, you may have recognised the building if you're from Wolverhampton. So this was a project that we did where we visualised the now not so new science block at the North Campus at Wolverhampton, and it enabled people to explore it. And anecdotally, at the time, there were lecturers and that who were exploring the model, going to where their rooms were going to be, and having a look out of the windows to see what their view was going to be. So, I mean, a bit of fun, but actually, it's a viable thing. So what have we done with it? Okay, so interactive site plans have been really quite a big thing, really. Being able to visualize visualize construction before it's been built. at the planning stage possibly, or even before that, the optioneering stage. Bottom right hand there, we've even used Sketchfab. You've got limited options for interactivity, but you are able to create some stuff that goes onto Sketchfab, and obviously the beauty of that is it's available to anyone with a web browser. So the bottom left image you can see there is Oxford Science Park. That was one of the first big projects that we did, and that whole project started from Seven Partnership, our parent company, going and doing a mobile mapping survey to create a point cloud of the whole site. We generated a 3D model from that point cloud, and then we added in new buildings that were going to be built. And then you can see there, you could just navigate it, click on the building, get some metrics, and it was used as a point of sale tool by the guys on the site. And this is actually the building that they hadn't built yet, called the Schrodinger building. So if you go there, maybe you can let me know if it actually looks like that, because I've not been down there since. So it's a big touch screen, very easy to use. I mean, the guy who we sold it to won't mind me telling you this, but he was the least techie person I think I'd ever met. And yet he was able to use this tool to sell office space off plan. So really nice kind of use case for the technology there. And so we were doing VR projects. So the bottom right there was using the old Oculus DK1. We created a training simulation prototype for the rail industry. It was fantastic. You've got trains coming past you in real size with sound and everything like that. It was scary. It was such a good idea. They went to develop their own. But then I think that's the nature of being at the cutting edge, isn't it? At least we were in there at the beginning, showing people what was possible. And then if you don't recognise it, on the left there is the Halley base on the at the Antarctic survey. So those screenshots are from a VR installation that we created for them for a museum. So again, really good use case. Not exactly construction, but definitely a good use case for immersive VR. Okay, so I'm going to spend a little bit more time on this slide. So this slide was this project, was produced for Oleo Water for their it was one of their Christmas kind of get-togethers. The whole company got together, and each independent area of Veolia had to create a breakout session. Oleo Water approached us to see if we could take a model of their high-pressure steam water treatment plant that actually is at Oxford as well, strangely enough. And if we could take that 3D model and we could make a big interactive kind of showcase, basically, about where VR was going and what you could do. Very interesting, really interesting to watch people who work at this site actually use the VR and come off and go, oh, it's really strange, I recognised everything. And actually, strangely enough, that also works the other way around as well. So if you immerse yourself in a VR space that exists in real life, much like Street View does, when you go, if you get a chance to go to that real life, you will find you will have memories of where things are. You will have spatial memories based on your experiences in VR. Very powerful tool. So basically, the people were able to navigate themselves around the site, teleport or walk, interact with like valves to see feedback, and get manuals for bits of kit by clicking on them. And it was very much a kind of a showcase. And we, as you can see there, top right, there was a big screen with a third-person view that everyone else who wasn't in VR could see what was going on. Because that is an issue with VR sometimes, is that it's very isolated. And this is why I think both myself and Dave are very excited about the social VR movement that's now starting to gain traction in the industry as well as wider public. So that was, I would say that this was our first big VR project. So strangely enough, after that, we did a project for Shropshire Council. They bought a big sort of 360 circular cave, as it's called, So a bit like the curved screen that I used to use at the university, but all the way around with projectors in it. And it was for an assisted living village that they were trying to showcase, and they wanted to actually, to be honest, they wanted to show a government minister, and that was the whole point of it. So we took the designs from Ridge Architects, and we took the Revit model, and we processed that, and we use Unity Game Engine, as Dave said, it's our tool of choice, and we were basically able to create this immersive space that you could walk into, and you could use a standard kind of joystick to move forwards in whatever direction you were looking at the time. Very, very, very cool. In fact, the people Igloo, the people that make the device, if you like, the cave, have since told me that they took some images of that because it's the best thing they've ever seen running on their system. And I must admit, we pushed the capabilities of their technology to the nth degree, which was an interesting experience. But as far as an immersive collaborative space, I think there are still really good use cases for caves. There are issues. It's a bit of a letterbox. As you can see, there's no floor. So it's a bit of a letterbox, but I think in some cases it's very, very useful. Get people in there and get them kind of talking about the same 3D content. So, and this is the final one, really. I think this is for me, this final project would not have been possible without the Oculus Quest. So, NSG, or basically Pilkingtons, we do a lot of other work, non-VR work for them, but they approached us about this problem they've got in one of their factories, whereby they basically had a human factors issue. In as much as they were changing all the equipment that their operatives had to use, but they wanted to get buy-in from their operatives before they installed the machine. In fact, not even before not even before the machine was installed, even before it was finished designing. So they wanted the operatives to be able to give input into the design of the new machinery. I mean, basically, so that they didn't have any kind of issues going forward when the operatives needed to use the equipment. So what you're seeing here is a screenshot of a very quick collaborative session, excuse me, that I was having, and the guys at NGF have kind of annotated something they need to change, and that's a top view of the model. So that was one part of it. They send us the models. We used a tool called Pixies to process and optimize the model so that it can go into Unity. So this removes a big barrier. So without tools like Pixies, it can take a lot of re-engineering time, a lot of 3D modeling time to make Revit models and Inventor models work in real time. But tools like Pixies now, Pixyz, are able to automate that process a lot, which is absolutely fantastic. So go to the next screen. So you can see here we are immersed in the actual model. So guys could move around. I haven't got anything here. They could actually take measurements. But the most useful thing that they could do was actually go and stand on the machine where they would be standing if they were operating the machine, and get a feel for it, and give feedback back. They could give feedback back to the guys who were designing it. And actually what was happening was we went through 4 iterations of this app, because what was the feedback was then going back to the designers. They were tweaking the design. They were sending the design back to us. We were republishing the VR experience, and then it went through 2 or 3 iterations, as I said, and they loved it. In fact, halfway through, they said, "Is there any way that we can have a top-down view?" So we did something in VR that you can't do in the real world, and that has enabled people to hover above all the machinery so they can get a top-down view. I think the most exciting thing about this for me is it's where I feel a lot of technologies and a lot of processes have come together to enable this to happen. They found it very useful, as I said, and we'll be using this approach going forward, because with the Quest it's so easy. You haven't got to spend half an hour setting up your trackers. You literally just throw the headset on, draw your space out where you're going to be, and then bang, you're in VR. I think that that's pretty much everything I've got to say. I think what I'm going to do, just off the back of what Dave said, I'm just going to drop a link into the chat there, and this is a new tool that's just come out, Resolve BIM. So Resolve BIM is absolutely incredible. So it enables anyone to stream Navis or Revit or anything else, any other kind of model that you get into BIM 360 in the cloud. It enables that model to be streamed in real time to a standalone Oculus Quest. Okay, so this is a bit of a game changer as far as I'm concerned. So it enables not only that, but it's collaborative. So you can send links to everyone, and 2 or 3 people can join in and walk around their Navis model, walk around their Revit model, mark it up. And I think, I don't want to be corny, but like literally the future is now. Thank you very much. So does anyone else want to say anything? Paul. Yeah.
Well, thank you very much, Nigel, and thank you, Dave, for those brilliant presentations. Fascinating stuff. Has anybody got any questions they'd like to ask? If so, please type them in the chat box, and we will do our best to answer. And we covered a range of topics there, including all the latest gear as well. Has anyone got any questions on which equipment to buy? Oh, thank you.
Any good open source BIM software for end users to do a first cut of their design? I think that's you, isn't it, Dave?
Yeah, I'll pick that one up in terms of the open source stuff. It's an interesting one because it's one of the areas where there isn't a huge amount. One thing I would point to, because they do seem to be doing a lot of work and moving towards the BIM, is a tool called FreeCAD. And that's, if you're on social media, you can follow them on Twitter or hit up their website. It's well worth a look at them and see where they're doing. Yeah. In terms of, and I'd say that's probably the best bet at the moment. In terms of some of the 3D modeling side as well, there's also a package called Blender, which is an open source tool, which allows you to do some sort of 3D modeling within that as well. Yeah. So they're probably the two I would suggest taking a first.
So, if I could just jump in there, Dave. So for Blender, you can also get the open BIM plugin for Blender, which actually allows you to not only load IFC models, but also allows you to a certain extent, author IFC models. So yeah, I think Blender's a really good. I'm just going to very quickly pick up on the how does this tech link to digital twin? Thanks, Neil, for that question. Great question. Okay, so how does this link? Very, 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 very well. In fact, to my knowledge, there are 2 packages which are basically plugins for Unity, which allow you to build up your digital twin. So it enables you to do discrete event simulation within Unity. It enables you to link to control systems by Siemens or by TwinCat, and enables you to basically model up, take the BIM, and then using their specialist animation tools, create an actual simulation of your factory, for instance, and then link it to control systems in the cloud. Even IoT systems using MQTT as well are supported. So I think absolutely game engines for digital twins is a runner. Fantastic, yeah.
If I can pick up on Carol's asked a couple of questions here on which camera to use for the 3D modeling, and then are we using aerial 3D or just terrestrial scanning? And I guess there's probably multi-facets to that to this response, I guess. in terms of some of the 3D modeling, where it's from scratch and design work, we're designing from scratch, maybe using one of the tools like Revit, for example. In terms of if we're designing for an existing building, then we would generally, from our point of view, we would use a terrestrial laser scanner to capture that. Sometimes we might also jump in if we want things like roofs and to generate some kind of 3D data for the roof. We would use a drone to go and capture that, and then generate a point cloud from that drone as well. And then that would form the sort of basis in one of our sort of CAD, for want of a better phrase, or BIM packages to actually do the 3D modeling on. Notwithstanding that, another thing that's really interesting to look at, and I briefly mentioned it earlier on, is in terms of generating that point cloud data, you can now bring that into the Twinmotion VR software. And so you can engage with, walk around, visualize that sort of 3D environment and visualize that point cloud data in real time within a VR. And so that could be alongside a new design as well. So we do use a lot. We also use a Matterport camera, something called a Matterport camera as well. And I know the guys at Seeable also use that. So we use it within the research lab, and I know the guys at Seeable use it. So we use something called a Matterport camera, which is a photogrammetry-based camera that's great for indoor modeling, but not so great in terms of capturing outdoor data. It uses a combination of photogrammetry and infrared sensors to build up fairly low resolution 3D models. So it's a bit of everything, Carol. I guess in kind of response to that question, we're using a bit of everything. Predominantly, though, I guess most of the time it would be terrestrial laser scanning to generate a point cloud.
Up on Peter's question there.
Well, where are we?
Is there any research on the productivity benefits in construction processes?
There's been some. It's a little bit old now in terms of productivity processes. I haven't got the. There's a link to an piece of academic research that was done in terms of that, and I'll dig that out, Peter, and we've got your email address there. I'll send that over to you. But it did show there has been some linking it back to the sort of 4D side as well, and that showed some sort of increases in productivity. I guess it's in some respects, a really difficult one to benchmark, and I know that's one of the things in the particular study. It was a difficult thing to benchmark because you never have a complete control group to benchmark it against. So I know certainly when it comes to some of the 4D stuff, it was sort of saying, well, it reduced the number of RFIs on a project, but then you don't run exactly the same project twice. So you kind of, I guess it's a little bit more difficult to generate a real control group. But I'll dig that out, Peter, and we've got your email there. I'll fire that paper over to you.
A question from Hamlet as well. What software can be used to optimize .obj for immersive experience in VR?
So yeah, I'll just jump in with that one. I've dropped a link below that to one very, very good example, Pixies. So Pixies there's two parts to Pixies basically. There's a standalone kind of Pixies Studio, which enables you to batch process very, very large models. And what I mean by process, it does all the cool stuff that lets you run really complex models in real time, but also which take a lot of time to do yourself. So creating multiple levels of detail of an object and then switching those out depending on what distance you are from the camera at the time. Pixies is very good. It's also got a plugin which plugs into Unity, which does a very similar thing. So it enables you to bring your models into Unity and then process them with Pixies in the editor. Very good, pretty much industry standard. On top of that, I would say that actually Unreal, as a game engine, does have some tools for doing auto optimization. It can work well. However, I will just say your mileage may vary with that. I find Pixie's a lot more usable tool. Yeah, I think it's fantastic.
Neil, go on here about building diagnostics. Can you use thermal imaging? What's been done in this space? So I guess, well, there's something that I'll come back in a minute. There's a project that Nigel and I did with Seeable a few years ago now, and it ties into the digital twin thing that I mentioned earlier. But in terms of, I guess one way you could do it is you could map the thermal image results back onto the VR model so that you can see the results in kind of real time. So that's one way. Although that's fairly static, one would argue, because once that map is on there, it's a snapshot of what the thermal image was in that point in time. We did some work a few years ago, probably about 5 years ago now, Nigel, I think it was, where we within the Unity engine, we took the sort of BIM data and we took live temperature sensor data, and we used that sensor data to create almost like a heat map within a building. So it was color coding the different rooms and the different places in the building based on that, and then we expanded that out to away from just thermal, but it went to occupancy, it went to power, water usage, various. Right. So that was a more dynamic approach, because it was constantly polling the sensors and generating it was changing the model on the fly as the sensors were changing. Well, in terms of using the thermal image, yes, you can do that, but the model would show that image at a snapshot in time, so your model would almost be like a time freeze of it. Is there anything you want to add to that? Is there anything extra?
Well, no, not really. I mean, what's occurring, what's popping up in my mind is machine learning, basically, and how machine learning is now very easily accessible using Unity. Unity have enabled a kind of close knit kind of solution with Google's TensorFlow. So you could actually maybe look at using machine learning to kind of process the thermal imaging data as it's coming in, but not really. No, I think you're right there, Dave. I think that's it. I just wanted to pick up a question that Paul asked. He said, can the Quest be used external environments? Well, very much like the Matterport, yes and no. Okay, because it's using computer vision basically. So if it's a very, very bright sunny day, then no, there's no chance of you using the Quest outside. But if it's a slightly overcast day, then you will have pretty good kind of experience of it. And I've seen evidence. If you put the Quest into developer mode, you can actually turn off the boundary, which means that you can just wander around as much as you like. And I've seen some experiments done where people are outside actually walking around massive models because it keeps tracking you. As far as you're going, it's just tracking you. It's pretty brilliant. So yeah, Paul, in answer to that, yes and no.
Thank you very much, everyone, for the questions. I'm mindful of the fact we've overrun a little, and apologies for that. But it was a fascinating presentation by Dave and Nigel. And do we have one final question? Perhaps we could take one final question from Angelica before we go.
One from Angelica there. So it just pops up off my screen. Hang on a second. Where's one? So I can see one come in here. I know you mentioned some existing future directions for including smell and taste. What about considering things that simulate the room environment, natural light, and ventilation? There is a lot of. That's a great question, Angelica. There's a lot of other things happening in terms of this. In terms of natural lighting, that's the algorithms that support lighting in VR are getting so sophisticated and so much better now. In the past, we've almost had to mimic ambient light within a room by doing some kind of fudges and fixes. But the algorithms that are sitting behind it and the hardware that can drive it now are allowing us to actually position buildings in in real geospace, and then give it a time and a day, and it will read in the weather data, it will read in the sun latitude and longitude data as well, and it will give us actual simulations of it. And I think probably Twinmotion's got a really great lighting system sitting behind it that will allow us to do that. In terms of ventilation, I guess that's a bit more of a tricky one. In terms of feeling that ventilation, I know if you go to Disney, they have the 4D rides, and Shrek 4D. I've done that one where the wind is actually blowing through your hair as it's going through. So that's another one. I haven't seen anything that's sort of taking that into account yet within a building, and I know that would be great because you could sit underneath air conditioning units. We know what that's like when we sit underneath that. That's terrible. So there might be some things. Something I haven't thought of that, and I'll take a look into that because I think that's quite an interesting concept. But certainly from the lighting point of view, the natural lighting point of view, yeah, the systems now, the technologies now are starting to get more and more sophisticated to allow us to do that.
I think that's it then. Thank you for all the questions. Thank you everyone for taking part, and I hope you all enjoyed it. And we hope to see you next time. 30th of July is our next event, 11:30. Look out for the flyers on that one. And thank you all for participating.
Thanks everybody.
Thanks. Cheers.